Good morning children and welcome to online teaching session. Today I am going to teach important topics like electrometric effect, inductive effect, right, and then hyperconjugation. These are the three important topics or concepts, whatever you say. But in all these three things, displacement of electrons takes place. So whenever electrons are delocalized or displaced or they leave their place, right, and move to some other place within that molecule, or move to some other atom within that molecule. That phenomenon is said to be electronic displacement. And this electronic displacement has some important effects. Now let us see these one by one. First, we will move to electrometric effect. In this topic, electronic displacement of covalent bond, we have a concept like hyperconjugation. Hyperconjugation. Now let us see what is meant by hyperconjugation. This is also known as no bond resonance. What is meant by hyperconjugation? Why is it called no bond resonance? Right? And in what type of compounds this hyperconjugation effect will be more? These are the things which I am going to teach today. In this phenomenon, hyperconjugation, the bond lying between carbon and hydrogen, that is covalent bond. When only one covalent bond is there, we can call it as sigma bond or sigma covalent bond. Right? When one more bond is there, then that will be pi bond. But when two bonds exist, we can't say specifically which is pi bond, which is sigma bond, just looking at the structure of the molecule. So now we are going to see how the electron in the form of sigma covalent bond is delocalized when it leaves its position. Its position is between carbon and hydrogen. It moves to other carbon atom. That means that covalent bond will be no more in between carbon and hydrogen. As a result, entire structure will attain double bond. Entire structure will get one double bond. This phenomenon can be understood with the help of ethyl cation. Example for this is ethyl cation, that is C2H5 plus. Carbon will get that positive charge. Now let us see this in the form of structure. Here we have two carbon atoms. So I will show two carbon atoms in this way. Right? It is ethyl molecule. So first carbon atom will have three hydrogen atoms. And next carbon atom has two hydrogen atoms. and this carbon atom has positive charge. So this is ethyl cation. As I told you, hyperconjugation means the bond lying between carbon and hydrogen. Means it can be any bond. We have three bonds. We have three carbon hydrogen bonds. In between C and H, one bond is there. Like that, see C and H. Like that, in between C and other H, one single bond. In that way, in between C and H, another bond. So in that way, we have three bonds. So any bond can be delocalized. For example, if this bond, imagine, gets delocalized. As a result, we will get a different structure which looks like this. Right? This bond is delocalized, means here this bond should not be shown, but hydrogen will be there as it is, right? And then the remaining two hydrogen atoms over first carbon atom, and two hydrogen atoms over second carbon atom. Since this bond delocalized, right, means it has left its position and occupied the place lying between two carbon atoms. That means this will be that bond. Since this bond moved away from hydrogen, so hydrogen will get plus sign. Since electron density is lying more towards this carbon atom now, therefore positive charge lying over that carbon atom vanishes. Right? So we can show these two structures with the help of opposite headed arrow mark. Next, in another structure, what happens is, instead of this bond can be delocalized. When this bond delocalizes, this hydrogen atom will get positive charge and double bond will be there as it is here. Right? So that structure can be shown in this way. Right? So double bond is there as it is. In next structure, what happens is, this pi bond will, imagine, it has come back in between this carbon and hydrogen. And the bond lying between this carbon and hydrogen gets delocalized. Or, look at this structure, instead of this bond now, this bond, the other bond lying between carbon and hydrogen can be delocalized. Then we will get the structure like this. It means whichever bond lying between carbon and hydrogen, right, when it vanishes or undergoes displacement, vanishes means leaves its position and occupies the position lying between two carbon atoms, right, then that hydrogen atom will get positive charge because of movement of what do you call sigma bond or covalent bond away from it. When covalent bond means electron pair, sigma bond means electron pair only. So sigma bond is one of the types of covalent bonds, right? So when that bond means electron pair or electron density moves away from the hydrogen, that hydrogen will get quite opposite charge to that of electron. That is why here it is shown positive charge. So in all these structures, you can see the bond line between carbon and hydrogen has moved, has left its position. That means there is no bond between carbon and hydrogen. Carbon and hydrogen. That is why it is said to be no bond resonance. No bond resonance. This is the other name given. So once again, hyperconjugation is nothing but a phenomenon wherein the sigma bond or single covalent bond lying between carbon and hydrogen leaves its position, its place, and occupies the place lying between two carbon atoms. Already in between the two carbon atoms, one sigma bond is there. So when the bond lying between carbon and hydrogen leaves and occupies the place lying between carbon and hydrogen, then it will become double covalent bond. Right? So in this phenomenon, in all these structures in between carbon and hydrogen, sigma bond lying is disappeared for a while. So in these structures we can see absence of bond between carbon and hydrogen. That is why it is said to be no bond resonance. So all these structures represent ethyl cation only. Next, here in this structure, this is one alkyl group. Right? And it is methyl. Name of this alkyl group is methyl group. Imagine a structure, here we have only one methyl group. Imagine a structure which has two methyl groups. Then in that, hyperconjugation will be more. And stability will be more. So more the number of alkyl groups in alkyl cation. This is alkyl cation. Since we have two carbon atoms in it, so we call it as ethyl cation. In this ethyl cation, we have one methyl group. Right? Methyl group is also an alkyl group. So as the number of alkyl groups increases, stability will also increases. Now we will see order of stability in the case of those compounds wherein number of alkyl groups are variable. Now let us see one example. This is one alkyl group, second alkyl group, this is third alkyl group. Now this carbon has positive charge. So this is tertiary butyl cation. Tertiary butyl cation. It has three alkyl groups. Now we are going to see a structure wherein we have two alkyl groups. Two alkyl groups are there, right? And they are connected to one carbon atom. other structure we will see. In this case, only one alkyl group we have. In the last structure, look at this. In this case, only one alkyl group, means there is no other CH2 methylene group connected to it. And when we move from left to right, number of methyl groups decreases. So one which has more methyl group will have greater hyperconjugation effect. Right? Next, when we compare these two structures, in this case we have two methyl groups. So in this case, hyperconjugation interaction will be more than the other. Now if we compare these two, in this case, hyperconjugation of ethyl cation is greater than the methyl. So this is methyl cation and this is ethyl cation as I have written here, and this is propyl cation, right? And this is ethyl cation. So what is required to remember here is hyperconjugation interaction or phenomenon will be more in the case of that compound which has methyl groups number more in number, more methyl groups than the other cation which contains less number of methyl groups. So more the number of methyl groups, more will be the stability. Less the number of methyl groups, less will be the stability, and less will be hyperconjugation effect. So that's about this phenomenon, that is hyperconjugation, right? That is one point. That means more the number of alkyl groups or methyl groups, more will be stability and more will be the hyperconjugation phenomenon, effect or interaction. Next, since there is no bond between carbon and hydrogen, therefore this phenomenon is also known as no bond resonance. So that's about hyperconjugation phenomenon. Yes, children. Now we will move to electrometric effect. It is also known as E effect. Now let us see what is meant by electrometric effect. Electrometric effect, first of all, it's a temporary effect wherein compound containing double bond, especially compound containing double bond, will exhibit this phenomenon, right? And this phenomenon will take place in presence of attacking reagent. Reagent means chemical substance. That reagent may have either positive charge or negative charge. Once again, electrometric effect is nothing but an electronic displacement, right? And this phenomenon takes place in the case of those compounds which contain double bond and in presence of attacking reagent. It occurs. Now let us see this electrometric effect in two different ways. First one is attacking reagent is going to attack the compound containing double bond to a particular carbon atom. Imagine in this case, right? Here we have double bond between these two carbon atoms. So we can say this is unsaturated compound, right? But the thing is, according to this phenomenon, there must be two bonds between two carbon atoms. We have now attacking reagent that may have positive charge or negative charge, means in the form of ion it can be shown. Imagine it is possessing positive charge like this, right? Now for a moment, one of the two covalent bonds which is weak, right? Whenever two bonds are there, out of those two one will be weak, that is said to be pi bond. If three covalent bonds are there at a time, then in that two will be weak bonds than the other, right? So here one of these two bonds, one bond is sigma, other one is pi bond, right? Imagine that pi bond is moved towards this carbon atom. As a result, this carbon will get negative charge. So this positively charged species, this is attacking reagent. This positively charged species can attack this carbon, because whenever displacement of this pi bond or electronic displacement, pi electronic displacement according to the title, okay, takes place, this carbon will get negative charge for a while, right? And this pi bond is moving away from this carbon will get positive charge. Means it will be like this. Now look at valency of this carbon, 1, 2, 3, 4 satisfied. Valency of other carbon atom is not satisfied. So they, over that carbon atom, we need to show positive charge. So it will be like this. You can understand in this way. Double bond, carbon, double bond, again carbon. When this bond is delocalized for a while, or when it moves towards this carbon atom, then it will become negatively charged. Right, other carbon atom positively charged. In this way, polarity will be developed. And since attacking reagent has positive charge, so it attacks this negatively charged carbon. That's what shown in this structure. This is one type of electrometric effect, wherein one of the two carbon atoms has attained positive charge ultimately. Next, in second type, we are going to have a second attacking reagent. It is like this. So in this case, same thing. Pi electron or one of the two covalent bond moves close to the carbon, so that will get negative charge, right? Then the attacking reagent, which has quite opposite charge to this reagent, that is say cyanide, So here cyanide is attacking reagent. As I told you, reagent means chemical substance, right? So this carbon will get negative charge, the other carbon atom will get positive charge, right? To that positively charged carbon atom, this cyanide attacking reagent gets bonded. So it can be shown in this way. So in the case of first phenomenon, attacking reagent is positively charged and that has led to the formation of a particular substance wherein carbon has attained positive charge. So this type of phenomenon is known as plus E effect. And the other phenomenon wherein negatively charged cyanide radical has attacked and that electrometric effect nahi aaya hai. Second one. Now let us see electrometric effect. In that also electronic displacement is going to take place. So under this we have the other concept, that is electrometric effect. This is also called E effect. Now let us see what is meant by electrometric effect. So electrometric effect refers to a phenomenon wherein electronic displacement is going to take place. Number 2, those compounds which have double bonds in them, they exhibit electrometric effect. Number 2, because of this electrometric effect, the compound which we are going to get in the form of charged particle will have either positive charge or negative charge. If it is going to possess positive charge, then it is given a particular name. If it is going to possess negative charge, then a particular name is given to it. Right? Third point. In this electrometric effect, electronic displacement occurs in presence of an attacking reagent. That attacking reagent may have positive charge or negative charge. Right? So if it has positive charge, it is going to give a product in the form of ion with positive charge. So that type of phenomenon or effect is known as positive electrometric effect. If the product in the form of ion, if it is going to retain or going to get negative charge, when negative attacking reagent attacks the compound possessing double bond, then it is said to be negative electrometric effect or minus E effect. Now let us see those two. So here electrometric effect is divided into two types. One is positive electrometric effect. This is also known as plus E effect. So in the case of positive electromeric effect, compound containing double bond. Example. So this is one compound wherein in between two carbon atoms we have double bonds. Now on either sides of carbon atoms also we have double bonds. So they may be in contact with methyl groups or ethyl groups depending on the length of the chain. So that is not required for us. The only thing is compound should have double bond in it. So it can be alkene. Now in this case we are taking H plus as attacking reagent. Right. Now, one of the pi bonds, according to the main topic, electronic displacement and covalent bond, means out of these two bonds, the weaker bond, that is pi bond, right? That pi bond is nothing but covalent bond only. That undergoes delocalization, means it will move towards one of the carbon atoms. So that carbon will get negative charge, means it will be like this. When that double bond shifts towards this carbon, then this carbon will get negative charge. Since that double pi bond lying in the double bond moved away from this carbon, so this carbon atom will get positive charge in this way. Means polarity is developed. Attacking reagent has positive charge, so it will attack the carbon which has negative charge, because opposite charged particles or opposite poles will attract each other. As a result, we are going to get the compound with a particular charge. Means it is nothing but ion. This is the product with particular charge. The charge is nothing but positive. Right? Attacking reagent attack carbon with negative charge. So the charge left over is positive. Attacking reagent has positive charge. The species which we got also has positive charge. So this is what you need to remember. In positive electromeric effect, attacking reagent and the species, the ion which they are going to get will have positive charges. So that's about positive electromeric effect or plus E effect. Now let us see negative electromeric effect. This can also be abbreviated by minus E effect. In this case also same thing. Electronic displacement is going to take place. Right? Now, listen, the difference between these two. In negative electromeric effect, the attacking reagent has negative charge and that is not going to attack the same carbon atom which was attacked by H plus ion. Right? So it will be like this. This phenomenon is also exhibited by the compound possessing double bond this way, and here attacking reagent is Cl, cyanide. Whenever attacking reagent approaches the compound containing multiple bond, then only delocalization of pi bond will occur. Right? as a result this carbon atom is going to get negative charge. The other carbon atom will get positive charge as shown here. Attacking reagent has negative charge, so it will attack positively charged carbon atom. That means we are going to get the product, right? It is in ionic form, and that will be like this. Now in this phenomenon, attacking reagent and the product both have same charges. Cyanide has negative charge. Attacking reagent also has negative charge. So the phenomenon wherein electronic displacement occurs in such a way when the attacking reagent has positive charge, thereby to result the product with positive charge, is known as positive electrometric effect or plus E effect. Next, the phenomenon wherein electronic displacement occurs or displacement of pi bond of the double covalent bond occurs in such a way when attacking reagent with negative charge reaches the compound, and that leads to the formation of ion with negative charge, is known as negative electrometric effect or minus E effect. So that's about electrometric effect. So electrometric effect is nothing but a phenomenon wherein electronic displacement takes place, and this phenomenon is exhibited by the compound possessing double bond. In that compound, one of the double bond is pi bond, which is weaker than the other bond. Other bond is sigma bond. So when the attacking reagent approaches that compound, then that pi bond undergoes delocalization, means undergoes displacement, which leads to the formation of a particular polar particle, and attacking reagent will attack that carbon atom which has quite opposite charge to that of the attacking reagent. So that's about electrometric effect and the different types of electrometric effects. Thank you, children.